Hi guys, in this segment we're going to talk about how the Earth was made. About 4.5 billion years ago, the Big Bang occurred, and from our sun, particles were shot all through the outer space, and as they came together and cooled, they formed Earth. The Earth is made up of four basic layers. On the inside, it's very hot and molten iron, almost pure iron. And as we get out to the second layer, which is the outer core, it's also made up of iron, but it has other minerals that are still roughly about 2,000 degrees, so they are liquid. As we get out from the outer core, we have our mantle. In the mantle is a bunch of churning minerals and uh, what we call magma. And magma is basically lava underground. As we get out from the mantle, which is constantly churning in a convection current, we get out to the crust. And the crust is the outermost layer of the earth. The crust is what we live on. And basically, the crust floats on top of the mantle, just like a jigsaw puzzle. It's kind of broken up into many pieces. As you can see, when we've seen the pictures of our Earth, we see the different continents all over. But in the beginning, Earth was basically one big solid mess, and there was a supercontinent, and it was just one big giant continent, and that one big giant continent was called Pangea. As the Earth began to cool, it formed what they called a supercontinent, or one big giant continent, that was delineated by German meteorologist Alfred Wegener in 1912. He called it Pangea. Wagner coined the term Pangea, which in Greek means all of the earth. And he determined that the crust was actually floating on top of the mantle, much like a ship would float on the ocean. As it floats, it moves. And this movement was coined continental drift. As the movement below the earth began to churn, the continents began to break apart. In geologic terms, the continent of Pangaea was formed a little over 250 million years ago in what they call the early Permian period. And at this time, Pangaea was surrounded by a giant global ocean called Panthalassa. As geologic time progressed into the Triassic period, we began to see the one supercontinent begin to break up, and they delineate it with two smaller continents in the Triassic period called Laurasia and Gondwanaland. We also see the formation of our first sea, which is a shallower ocean. That's the Tethys Sea. From 200 million years ago to about 140 million years ago, we have the next phase of our continental separation during the Jurassic period. Yes, we all know Jurassic Park from the dinosaurs, and they were roaming at that time around 145 million years ago. We also see the formation of our modern continents along with the oceans. We have the Atlantic Ocean and the Indian Ocean that are beginning to form during this time period. As we move from the Jurassic period into the Cretaceous period, we notice that the continents on top of the Earth look much like plates. And that's what we are going to term the breakup of Pangaea. It can be explained in the formation of plate tectonics. And these plates make up the outer shell of the Earth's surface, the crust. And these crusts sit on top of a layer which is called the lithosphere, which is basically magma. And as they float and they drift, they also collide into one another. They collide in convergent zones and subduction zones. They also break apart or rift apart. They are currently moving still today. We have 7 to 9 major plates that make up our continents. These plates have broken apart and come together throughout geologic time and are still moving today. As early as the 1950s, oceanographic vessels mapping the ocean floor provided data on the topographic features of the ocean basin, leading to the discovery of these mid-ocean ridges. These underwater mountain ranges encircling the planet form as the Earth's crust and the plates separate. As some of these plates separate, others begin to collide. The areas where they begin to collide are called subduction zones and convergent zones. A subduction zone is where an oceanic crust meets a continental crust. The oceanic crust submerges underneath that of the continental crust. Here is an example of subduction or a subduction zone. We also have convergent zones, and that's where two continental plates meet together and converge. And when they do this, this is how we form mountains. They converge and push together with nowhere to go, they move upward. Where two tectonic plates meet at a subduction zone, one bends and slides underneath the other, curving down into the mantle. However, when two continents collide, it's much like that of a car is crashing together. They do not subduct, they actually crumple together. And when you crumple together, they form a folding process, and that's how mountain ranges are formed. The massive Himalayan mountain range, or chain of mountains, was created in this way. This process creates both valleys and peaks. Peaks are called anticlines, valleys are called synclines. These processes are created much in the same way as if you took a blanket and crumpled it up from both ends. Basically would look the same. And we will be identifying 4 convergent zones in this class as we work through the mountain building process. Those 4 alpine folded mountains are the Rockies, the Andes, the Alps, and the Himalayas. We will show a few examples in the upcoming slides as to how this occurs or what this looks like. Here we see the folding processes as they take form in the Himalayas. You can see the actual rock has formed and bent up, forming these mountain ranges. And here we take a look at the mountain range of the Himalayas, which the folding process is clearly delineated here in this particular slide. In the next slide, we see our very own Sierra Mountains and how one plate has collided with another and pushed up the entire Sierra Mountain range. As tectonic plates push together in the mantle, there are hotter layers of magma, and that hotter layers of magma, they create fluids, and those fluids sometimes build up pressure and need to be released. That's what we call the creation of volcanoes. The ominous release of magma out through the Earth's crust is called lava. Another massive pressure release when these two crusts combine is called earthquakes. In no better place on Earth do we see these pressures take effect as we do in what's deemed the Ring of Fire. These subduction zones occur all around the edge of the Pacific Ocean, offshore of Washington, Canada, Alaska, Russia, Japan, and even Indonesia. The Ring of Fire is a giant subduction zone where 3 to 4 different plates come together and meet. The pressures are so great they release many earthquakes. Here is a classic example of how mountain building and earthquakes come together and form both valleys and ridges. So don't be fooled as you look up and see these majestic forces. They're maybe beautiful on the surface, but underneath there are many forces and pressures that have come together to form these beautiful upward lying mountain ranges that we so eloquently look at today. There are many, many forces underneath the ground that are still taking effect today that are pushing and pulling these earth processes all throughout the time.